All right. Hello, everybody. Welcome to the fourth day of the summer school. If you don't hear me, if you don't see me, open your eyes. Let's see, let's do this. So this morning, I found out that some food did not agree with my body. So if you hear any noises, it's just my body contributing to the lecture. But I hope it's going to go okay. So today is going to be a kind of a different lecture for you. Instead of diving into a particular method, I would show some case studies of how you can put some of this together and have a NLP pipeline that will go from raw data to some measure or graph or something you can put in a paper and, you know, pass your exam or something. So my interest is in public health. So there will be three examples of how to use NLP, and actually very, very simple. We're not going to be doing embeddings or any of these things, but very simple things to do to get to a paper, a study. So how does one create a scientific study? Perhaps you've seen the scientific method before, but of course it has many steps, and some of them, you know, have to go back, reconsider what you thought, et cetera, et cetera. And actually, in just about every one of these steps, you could use NLP to help you, or machine learning. So to be a little more concrete, what you might begin with is some hypothesis or idea. It could be very vague. And it's very nice to go to some previous literature to say, aha, what did other people do? So one of the first things you might want to do is collect some data for analysis. And already there, you will need to use NLP if you want to deal with text. So here, we didn't really mention information retrieval, but that is one of the first things that, that you will need to encounter. For example, for some of the data sets that I shared with you, you might already notice that they're really constrained by the keywords I used to get that data. And if what we got back for these keywords really depends on the search engine of Twitter, right? Actually, it's kind of pretty dumb. I think it's smart enough to maybe use both plural and singular, right? If I search for key, it will give me key and keys, right? But it doesn't have this smart embedding thing where it would give me something that is close to the word. But this first step is very important to get the keywords and the meanings that you want from your data. Then there are many, many refinement steps that you might want to clean your data to make sure that it is on topic that you meant it to be, that you don't want maybe some bots or other things that wouldn't be what you want in your data. So there you could do already a lot of steps of machine learning, right? You might want to train on some known data set and make sure that you know, what you have is passing some filters. And then machine learning and NLP will help you a lot in enriching your data, extracting all kinds of signals. So topic discovery is one, but you could do all kinds of behavior extraction, basically words that signify something you want to track. And we'll have several examples of that today. There could even be some social classification as well, how people interact with each other, what do they mean? Some of this could be textual data, but there could be other signals like who did I address in my tweet, or who did I connect, or who did I retweet? And many other things, for example, like geolocation, something that connects your data set to known information in the real world, right? I want to know where all of these strings of letters actually map geographically, for example. So all of this needs NLP, and lots of it needs machine learning. Then it's a good step to map something you found to something in the real world, offline world, right? This is not necessary for all studies, but it really makes it much more powerful, right? Something that you find in your data, if you can say, aha, it is similar to something that somebody else has found, especially if they did it using some other methodological approach, surveys or some other things. And in the end, of course, you need to massage it and perform some analysis. There, I think, I'm not sure if NLP, by then you should have like already good signals, and then maybe some more statistics or comparison between things will be necessary. And in the end, you draw some conclusions. So you can see that in most of these steps, machine learning and NLP can be used. Yeah.
About keywords. How do you just find the keyword selection?
Sorry, how do we
just find the keyword selection before the keyword selection changes everything, I guess?
Yes, the keyword selection is very important. So one of the ways to make sure that you get them right is first blame it on somebody else. You say, oh, we took some experts that have already written a study on it, and we took their keywords. That's, of course, actually not that great of a thing to do, because maybe they came up with these keywords for another reason, right? But it's still like an often thing that you see, that you just say experts came up with them. Or you can do it yourself with kind of a snowball method. You can say, I have some keywords that I can think of. I go to my data and retrieve some stuff. I read it and I find more keywords. And then I go back and forth, back and forth. And in the end, you have a set of keywords that you're pretty sure have good coverage and good accuracy for what you're looking for. Unfortunately, this method really makes it specific to the data set that you're looking at, right? So the way people talk about, for example, loneliness on Twitter is different from Reddit, is different from their personal diaries, right? So this keyword list would be biased. But it would be high quality, right? It probably would have good coverage and good precision. Does that answer your question?
Yeah, everyone will create bias.
Bias everywhere, everywhere. Every one of these steps, bias everywhere. Yes. Yeah. So no perfect solution ever. So today I will talk about some what they call lifestyle diseases. So that's one of the first things that I'll talk about. And obesity and diabetes are interesting cases in that they have really quite a bit of a burden on society and, of course, individuals, right? Extreme cases of these things really can kill people. On the other hand, these diseases are also considered to be connected to people's lifestyles. Although there are many other things that, of course, influence people's weight and behavior, for example, whether or not you have a grocery store nearby. Some of the choices that people make affect their bodies, right? And especially these diseases. And in fact, a lot of people around the world die of conditions related to it. So, but this is an interesting thing to study because it has not only personal, but also societal and environmental aspects, right? If I live in a wealthy place with a nice grocery store nearby, it would be maybe very different than if I live in I don't know, in the middle of nowhere with nothing but a pancake house nearby. So the social media is a great way to study this because it's socially acceptable for people to reveal what they eat. Of course, there is all kinds of bias, right? We don't post every single thing we eat. We post, maybe more memorable, more things that we would brag about. But even that signal is important in understanding what people feel like they want to share, right? What they think is shareable, like what their values are. So I will give you a few examples. For example, there is a study that looks at Instagram posts, and they basically calculate nutritional information that these posts contain, and they look at different posts from all over US and compare their these nutritional values in places that have food deserts. Basically, it's really hard to get food there, or healthy food, or not. And voila, they found that the quality of the food that they can find on the social media is actually different between these places. Or you could look at recipes. So this is text as well. You can extract some information from that and build some fun stuff like ingredient networks, where you say, aha, these cuisines are close to these cuisines, but not these other ones. And also relate this to some national health statistics and say, well, when you have I don't know, a lot of sugar, it's closer to obesity, etc. And finally, there is this cute paper that we wrote some time ago that uses Twitter posts to extract, again, some caloric values and relate them to obesity and diabetes numbers in the United States. And we can actually enrich this data with census, because we geolocate the tweets and we can say, aha, these people live in a wealthy place with lots of white people who are well-educated, right? And so even though we don't know these personal statistics about individuals in our data set, we can say in places like this, the statistics are higher or lower. So that's a cool privacy preserving as well as well, enrichment that you can do to your data. So often in these studies, methodology will go something like, you find your keywords, and maybe iterate several times to make sure you got good ones. You get to your data. Often you want to do geolocation, and we'll look at how that is done. You might want to enrich the text with some information, and that's often done with information abstraction. You extract something interesting out of it, and then you relate it to some known statistics. Sometimes people build regression models, or you can just run a simple correlation. So some of these things we will see today. So I've shared the notebooks with you. Some of you have already looked at them. I did not do the clever thing as Andre did yesterday, so I don't have like a nice setup file for you. So you can just, try to run the very first box, see if you have all the libraries, and if you don't, you just say conda install that library, and you do that until they're all there. I'm sorry, I didn't do it very cleverly.
I have a lot of location. So this location that you is some, or the location that the user just already time up the Twitter and say that.
Well, I'll tell you all about it in a few minutes. Yeah, the location is not trivial. Let's see. So I think it's this one. Aha. Okay, everybody sees it. So you can run it along with me, but some of the things take like a minute or two to run. So feel free just to follow along with me and try to run it later. So I include a whole bunch of things. I'm kind of actually a little lazy, so I include sometimes things that are not particularly necessary. So my apologies, but most of these things should be necessary. I have a couple of things if you are running it from Google Drive. So the case study of obesity here, we will do geolocation, food dictionary discovery, and correlation with known information. The time. Okay, very good. So you might have seen already this this first command where we're reading in text, and compared to many other things that you've seen in other previous tutorials, you might find that this is a big and unwieldy thing with lots of parameters. What is going on here? Well, what is going on is people's text is a mess. They have special characters, escape things, non-Unicode stuff. So it's often you need to say, like, be very careful when you read it in. So this is like all of these parameters that I might want to say. So this is a sample that I have of some tweets. It's always good to deduplicate your stuff. So here I'm doing it by ID. Often when you collect your information, especially it comes from the wild, from internet, duplicates occur. I've almost published a paper with like half of my data set being duplicates, right? So, ooh, that was fun. So if you look at it, you will find maybe some of the familiar fields, such as the text of the tweet, ID when it was posted, and some stuff about the user. So actually, this information has first arrived as a big JSON file, which was a lot thicker and it has a lot more information than this, but I just extract this and run with it. So how do we do geolocation? So first of all, what we want to do this with is the location of the user's profile. So some of the users actually specify where they're from. Funny part is that there is no constraint on what they can say. So some of them say on the wings of an angel, you know, or I don't know, Earth. Well, the funny part is that there is a city called Earth in Texas. And there is a city called Nome, just by Turin, where I live. You can guess that everybody who says none is living in that city in Italy. So there are many things that you will have to catch, right? Like special cases, exception, mess. So what I'm doing here is I found this very nice database called GeoNames, and there are several similar ones. Basically, they have lists of places on Earth. And the nice part about this is that they have different ways of spelling it in different alphabets. So, for example, here it would be, I don't know, Turkey in both Anglicized and local spelling, and maybe some other ones. So what I did was I separated it into two files. The first file is a dictionary. And who can tell me what dictionary, which is basically a hash table, is good for anybody who has computing training? What are hash tables good for? Okay, nobody. They're good for lookup. The lookup is super fast. So they're built the way that you say, give me this, and in no time it will find you the entrance. Okay, so for example, I can say, oh, give me the entry for Moscow. And this dictionary has a bunch of numbers that actually are different locations. Apparently, there are many Moscows around the world. So I give you this, this large piece of code that you really don't need to understand. One thing you might find, though, is this little block of me handling special cases of New York and people saying stupid things. And this is kind of, it depends on your special case. You know, if you want to favor bigger cities or smaller cities, or like whatever you know about your data set, perhaps you want to change these rules and get something specific out of it. But long story short, we can get the tweets that have some kind of locations and basically find the best match for geolocation for them. And we can see that out of 10,000, we find 6. So a lot of them, basically, we cannot geolocate, unfortunately. And then we take the columns associated with these geolocations, we add it to our table with the tweets, and voila, we have tweets and whether, what is the name of it, where it is physically, and some other interesting things about the location, including population, which is very handy. Okay, so we then can examine how well it did. So for example, somebody wrote Indianapolis in US, and we found Indianapolis in administrative code in US. Very good. I think there is a Italian one. Italian, did it work right? Yeah. Oh, excellent. But sometimes when you do this, you find bad matches. It happens. Like Nome. Okay, so we can even see like within the United States where people are in the biggest states. No surprise there. So, okay, so we find these things, and this is me doing it kind of manually. You know, I found the dictionary, I did the search, I did like lots of special cases. You could use many services available to you. So I did this because my data sets are really big and I had to do, I don't know, millions of lookups. And the services don't like it when you spam them with millions of requests. But if you have a smaller data set, you can actually just run one of these. So for example, this is a nominatum service where you say, here's a string, give me a location, and it gives you all kinds of information. Again, very, very similar where it is and what kind of location it is. So you might have to encounter that in your studies. If you can locate people, it's really nice, especially if you want to make some kind of claims about representability, right? Like that your sample is not all from California, for example. Okay, any questions about geolocation? Okay, it's a purely technical thing.
I have a question about the population. Is it only updated population?
You just hope that the whoever is keeping track of these things and geo names and other things are good at it. That's why you want like a good reputable place, right? You don't want to just grab any dictionary from it. I mean, some of these dictionaries come from, I don't know, open maps, right? On the street map and other things that, you know, they're really up to date. Okay, second part, we can now look at the text. So let's see. So now I want to find some food in my text. In fact, if I went to the original set of tweets there, I would find very few because it was a general sample. So here, this file is actually a sample of tweets where we were looking for foods. So we already had some dictionaries that not only did foods, but like dinner, breakfast, and other food-related things. So we have some of these tweets. And what we want is actually very similar procedure with the geolocation. We take a dictionary of foods and their caloric values. These are caloric values per 100 grams. So it's basically the density of the food that you're looking at. The funny part is that it's really hard to make this list because, for example, apple is now more of a company than a fruit, right? So if some of the words that we would find, or honey, how many people actually use honey as a food these days? So there are some of the misrepresentations that you can find, and unless you do something very clever, which people do, which is build classification models that will say, aha, this apple is fruit, and this mention of apple is company. Unless you do that clever thing, it's easier just to throw them out. But you might have to encounter that. And we do something very similar. So basically, we make a hash of our foods. And again, we do some kind of loop over our text. In fact, what I do is I try to find the longest match. So in this example here, I love my chocolate peanut butter cookie in the morning. Perhaps my dictionary doesn't have chocolate peanut butter cookie specifically, but at least it can say, aha, peanut butter, right? I'm not taking just peanut and butter. I have peanut butter, so I take the longest one. So you do the best you can here, find the best dictionary, do the best matching that you can.
Sure,
yeah.
How can you do this? Like, you find peanut butter and not the
yeah, so that's why we have two loops here. So the first matches all the matches. So it matches all the possible ones, and then it orders them by length and throws away the smaller ones, the subsets. Took some trial and error to tell you the truth. But yeah, it should work more or less. Oh, there's a. Yes, there exist food classifiers. Did you find a food classifier with annotations? It's best if you can, I think actually before creating this, like the way that we created this data set, we did have a classifier that told us whether it's food or not. Okay, it's from like a paper 9 years ago, so my memory is a little fuzzy. But if you can find, classifiers the thing is, the classifier has to be trained on data very similar to this. So if I take some classifier from like news or blog posts, it can be very different than it might not work very well on tweets because they're short. So I hope I answered that question. Thanks. Okay. So, but you get the idea. You find some things that you want to extract, you match them the best you can. And now we can do, okay, here we, I guess, are doing actual food discovery. So this is the one that will run a little slow because you take the tweet text and you apply the find foods, and the foods is what you find. We got a whole lot of matches in our data set. You can see that there's a lot of them here. And in the end, what we get is we get the caloric values for a data that we matched, and we compute the average caloric value per tweet, because we might be able to find many foods in one tweet, right? So we're doing an average here just to, like, if I have a long list of ingredients in one food, right? Like pepperoni, extra mushroom, whatever, pizza. I don't want to count as you've eaten all of these things separately, right? I'm just kind of interested in average, density of this thing. And this is after talking to people who are working on nutrition. So we have a bunch of numbers associated to tweets, and we can now get some real world comparisons. I think these are some of the examples. So fries and pickles, corn steak and broccoli, cheese, chili, and cheese is very heavy. Fries are very heavy. Okay, so we can average this not only per tweet, but we know where the tweets are. We take that information, which state they're in, and average by that. And now we have average energy that people post about in that state. Luckily, we have all kinds of health statistics about different states. We read them in. It's from, even census has some of these. So we have obesity rates in different states. We join them together. So now we have energy and obesity, and it's super easy then to say, do some kind of correlation between the two sets. And we have kind of some solid correlation. It's a bit different from the paper that I wrote, because I'm using slightly different both data and lexicon, but that's it. And you can even do a nice graph of this and say, okay, so we can see that, I think this is Missouri that has, both higher energy and high obesity, or Hawaii does not in both sides, or we have some outliers that we want to understand that don't seem to match the trend. So this is an example of a study. It's just this, but you can think of many other scenarios where you might want to extract something that then you can relate to a number. This has to be done very carefully with supervision of somebody who knows what you're doing, hopefully. But then you can do comparisons with the real world. And it's actually funny that in many situations, such as in public health, despite there being so many biases in how people post things online, you can still see a strong correlation. strongish correlation to what is happening in the real world, which is cool, I think. So any questions about this case study? Okay, so yeah, you have the code here. Feel free to, go through it. Maybe some chunks of it will help you in your project. All right, so let's get back to the presentation. Here's my presentation. Does anybody see my presentation? Did I close it? There. Okay, so our next case study is on mental health and in particular anorexia. So we're going the opposite way. So trigger warnings, it's not a happy topic. Although obesity is also not a happy topic. Okay, all of these topics are not super happy. But you could study the happy things too, but usually people don't pay you, money to say, yes, people are doing well. So unfortunately, we have to stick to the sad ones. So eating disorders are very similar to obesity and diabetes in the way that it's often, well, not only is it a behavior, but it's also a mental state, right? So there actually are, many anorexics who look quite healthy, but it is actually a mental disorder where people get obsessive about food or start doing strange restrictions. And of course, this is a very much of a range, right? All of us are slightly obsessed about our bodies, of course, but once you start going more and more restrictive or more and more obsessive, and especially when it starts hurting your body or your life, that's when people say that it's a disorder or something bad that we want to address. And there are many of them. And interesting thing about social media is that you can find support groups for people who are struggling with eating disorders, both in the way to continue doing it and in a way to recover from it. So there are things like AnaBuddy, where you are looking for a buddy to fast or to support each other in this mindset. But of course, there are many other big societal things that you can study, where you can look at body image and fitness culture. And I mean, if you've ever scrolled through social media, you can see beautiful bodies, perfect people. Surely it has some kind of effect on people's minds. So an interesting topic to study. Yeah.
There's one example mentioned there for orthorexia, and I could imagine that someone uses that just to mark if we really put a lot of effort into cooking something, right? And so if one goes for these things and just see that these strings, for example, well in a tweet, is it an operationalization of some measurement? What are you really measuring there? That's something what I always wonder.
Yes, so I think the question that you're asking, like,
It's
many things.
Technically extremely clearly defined what you're measuring. The technical definition.
Even that is not super clear, I'm afraid.
It is like what the consented part measuring is difficult. But this would be interesting.
Well, so if I understand it correctly, many things that we might be able to measure in text actually correspond to things in diagnostics that you would say people are, struggling with this disease. Is that what you're saying? So the interesting part here is that, yes, you could find a lot of things that suggest that people are struggling with some kind of thing, even with depression, right? who of us didn't say, I feel sad today, or I feel sad a lot, like these are very strange times. I think all of us have said this recently. But when does it become a disorder? That's a very big question, and that's a question even for the medical community, right? So often what we want to do is find markers that are actually unambiguous, right, about that people are having these disorders, or they're even self-identifying as that. So yeah, this is a difficult topic, yeah, definitionally. So for example, what we can do is study these groups that self-identify as anorexic, because they actually would go and post stuff, post pictures, for example, here on Flickr, and self-identify as some kind of anorexia. So this study, for example, was quite interesting because it looked at the interaction between the pro and the anti-anorexia communities. So some were actually trying to post and use similar hashtags so that people from the other side would be able to see their content. And funny but not funny thing that they found is that people who would actually be targeted in this way for some possible intervention would actually remain on the website and post about anorexia even longer. So it kind of backfired, right? So if you try to push onto people like, no, you're sick, you should stop doing it, it actually didn't work. So that's the sort of things that we can study with social media. And you can see that actually NLP might help here because a lot of social media websites, especially these days, are aware of this, and they try to block content that has certain keywords. Well, people are very inventive, so they come back with their new coded keywords, and it's a chasing kind of technological war. You could also look at people who have marked themselves as recovered, right? You could see, well, these people have said that they've recovered and these people have not. We could look at the past of their posts and say, well, how did the path to recovery look like? And compare these two populations. There's a similar study actually on depression and suicide, because some people might declare that they're considering suicide, and you can go back in time and say, well, what brought them to this point? So these sorts of things, okay, maybe even not mental health, but because social media is a historical record often, you could say, I find a marker of something I want to track, and you can look in the past and see what these people have said. Oh, this is one that actually does talk about the different spellings of anorexia and how to track it. I think they found that once you block some, the other ones come in, and often because of the new people who are joining, and they have new ideas. So some of these methodologies are, again, the data collection is actually somewhat keyword centric, but it also could be a user centric. So some of these studies were very lucky to find people that took surveys and said, yes, I'm struggling with this, and then gave them permission to collect their social media data. This would be the gold standard for your study, actually, because these are very sensitive populations, and it would be best to get their permission as much as possible, even though their expressions, their text, their posts are public, right? Anybody can read them. They're on social media. And then often what you want to do is do some kind of comparison, right? A and B, recovered or not, pro or anti. And to say, well, how are they different? Often it's in how they behave, maybe how much they post or how many connections they have, and importantly, in what words they use, what they talk about. You might want to look at particular issues, some topical focus, and do some linguistic analysis, not only in what they're talking about, but how they're talking about it. Sentiment analysis, of course, is a very popular one. You're using happy or sad words, but there are many other interesting things, like whether you're talking about yourself or other people, whether you're talking about us, you include yourself in a group of some sort, versus, you know, like, what is your mindset? Are you thinking of yourself as an individual or as a plurality? All of these things could be measured using libraries and resources that are available. So let's look at another notebook. Before we go to the notebook, does anybody have any other comments, questions? Okay, so let's switch over to that. I think, can I just say share something else? Very good. Okay. So by the way, right now I'm posting, I'm giving these data sets for practice, etc. I will definitely take them off like tomorrow-ish, right? Because I'm not supposed to be sharing these. This is not good. So, you know, you practice with it, and, you know, if you don't have a use for it, delete it, right? Because despite it being public, I reiterate, these are sensitive issues, right? Of course, I hope that you're not going to like find these people and start, you know, trolling them on social media. Yeah, but this is the worst case. Just assume you're not going to do that. But actually, when you write papers or something on it, and it will be on permanent record, what people do often is rephrase the tweets so that they cannot be reversed, re-identified. Right? Often what you want to do is take that tweet, put it in search thing, and see if you can get it back. Often you can, especially if it's a long one. So what you do is you rephrase it so that the meaning is kind of the same. So for example, here I have a data set that was identified to be anorexic, or people that are speaking in a way that suggests that they might be struggling with it, that are mentioning constraining, or they're self-identifying as this. And we have two files. One is for January, February 2020, and one is April, May 2020. What happened between these two dates? COVID. I hope that March 2020 is forever etched into your brain as a very strange time in our lives. And it's a very strange time in social media, of course. So, so we say that we have these tweets, some before COVID, some during. Actually, I had the answer right here in front of your eyes, so speak up. Okay, so we have these two samples. And we can see, so yeah, luckily I did not include the people's handles, but the tweets are here. And what we want to do is find the most distinguishing terms between the two sets. So this is a handy and extremely simple statistic that you can compute. So let's see, we have a bunch of text. What can we do with it to clean it up a little bit? So this is our text processing pipeline, some of which you've already seen in previous tutorials. For example, here I want to remove URLs, RT for retweets. I want to remove the hashtag sign, but not the hashtag itself, because hashtags are actually carrying a lot of meaning. We don't want to throw them away. We're removing the mentions of people and some other things that are not words or numbers or whatever. So we, in the end, get a version of the text that is clean somehow. So, yeah.
Follow same user.
So Twitter allows you to search historical tweets of a particular account back to 3,200 tweets. If this person has posted very often, a lot of posts per day, it doesn't go that far in time, right? But if this person didn't post very much, you can actually go back years. But the constraint is by Twitter API to get you only this many. But it's often sufficient to model a user, right? What they're interested in, what's their behavior in terms of when they post, who they talk to, etc. So it is possible to do user-specific analysis. Possible, definitely possible. Yeah. Okay, it's not possible if they've deleted their account. So, for example, if I find some interesting tweet here and I want to know more about their poster, the tweet I have, but the account may be gone now. So you might want to collect them quickly if you are interested in something. Okay, so we've cleaned our data a little bit. We've dropped some duplicates using the clean text. And this is nice because often even spammers say, oh, have very similar tweets, but are different URLs or something, or some small thing. So you want to duplicate it as much as possible. So we're getting some tokens. So now we have a bag of words. If you remember anything out of this summer school, bag of words. So we could then use the counter, which you might have encountered before in a tutorial, to basically take all of these tokens and count them, right? It just collects all the same one and gives it a count. And if you look at the top counted ones in the before and the during COVID sets, what do we see? What are these words called? Not teachers, please, students. Just scream it, just scream it. Stop words, they are stop words. Funny enough, anorexia is right there. Why is it there? Sorry?
We don't process the data.
Well, why is anorexia among my stop words?
High frequency.
Hmm?
High frequency.
It's very high frequency because we use that word to search for our stuff, right? So often the words that you're most interested in are actually the least important now because that's all you see in your whole data set, right? So you will have to, not pay attention to them. They become the stop words. So what I do is I download the stop words, I add a few that are Twitter specific, ampersand gets like this, retweet, let's throw it out. And so now, once we throw these away, we can actually see something more interesting, like people talking about eating and other things. Actually, ED is eating disorder, so that's why it's
We would
important.
advise to just adding the keywords to the stop word list or the processing.
Yep, I can put my query words in a stop word list.
Yeah.
Yep. Okay, and so what I want to compute is this thing called odds ratio. But basic idea, and I have a few links to Wikipedia and stuff here, is that I want to see, well, we've talked about, I don't know, beds, like this before COVID, and then like this after COVID, right? So is the mentioning of beds different between them? So for example, the word COVID, we talked about it before 0 times pretty much, right? Because it was named COVID like some time afterwards. And during COVID, it's like pretty much everywhere, right? So we want to be able to see like, what are these words that we're talking about more? And the long story short, you just have the normalized frequencies of how much we're talking about before compared to after. So we do some counts. So to normalize, we have actually these counts of people not saying a particular word. So for example, COVID was in our data set 0 times before COVID, makes sense, and sometimes during. So we do the ratio, and now we can sort our table. There's also a log that you can apply for it that is easier to interpret. So what we can see then are words that are more likely to be talked about during those months and not the previous ones. And you can do this for any two sets of users or whatever, groups. So we can see for sure that pandemic and COVID are up here, quarantine, lockdown. Other things might coincide with what you're talking about. So Ramadan probably happened during the later months. Is it important for eating disorders? Maybe, but sometimes you might pick up things that are just there for other reasons. And what is good to do is, you don't just like throw this into your paper, you try to understand what is happening. So you can look at, at instances of people using these things and do some samples and see how people talk about different things.
Very interesting.
It is. Sometimes it's very depressing, right? It depends on your thing. So yeah, Ramadan also, you can see how people relate this to their anorexia. But in the beginning here, you also saw these haya and cards. No idea what's happening there. So we look. So for example, for cards, we can see that some clever a spammer was actually using some kind of, come click on this link. And we were not able to deduplicate it because it actually uses people's names and we couldn't clean that out.
I have this about fake accounts. I know that these tweets are done by fake accounts, or know that they're.
Well, this could be a real person. It's a spammer, I would say. But
Just receiving the data, for example, is there any steps or any action can we do to just discriminate between is it the real account and the real signature, or?
well, there is a continuity between real and not real, right? So some accounts are altogether automated, right? They're automatic accounts, but they could be good. They could be like news, right? Like CNN might have a automatic thing. So it's a bot, but we want to keep it, right? Others are spam. They may be even real people, but they're spamming you. You don't want it, right? Others are a combination. So there is a very nice research group that works on bot detection, and not just one. There is this one that even gives you tools to say, okay, you put in the username and they will tell you all kinds of scores, like, is it a spammer? Is it automated account? Is it this? Is it that? And you could use these scores to clean your data set before even before you apply any of this. So it's possible. It's possible, but it's not perfect.
You know that there are some people on social media that they have many accounts and just all the time tweets, and then they try to, how can I say, influence the discussions.
Yeah.
So that's the one person, but I don't know that, but they influence the discussions and figures than many others, and about other things. So that actually an art. That's what can I say?
It's astroturfing. Yeah, they call it astroturfing.
Vegetable, for example. So that I asked that whether there is a kind of the quality of data.
There are people working on that thing, and there are algorithms that you can apply. Often you would need to collect more data for it. So detecting bots just from the text that we have here is difficult unless you have a, like this, like unless they post, I don't know, like 10 per minute or something on, very suspicious. Yeah, but often for these things, such as the astroturfing, which is fake grass movements, you can get them by understanding who's retweeting whom and how often, and build networks of collusion, right? And then remove these people if you want. So active research topic, super interesting. And it includes NLP, machine learning, and network science, which is very, very interesting. Yep. So all of this is possible. But again, like usually it's not 100%, and it's still good, even at this step, at the very latest step, even to still read through your data, and you might have missed something. You always miss something. People are clever. There's always something that you probably will miss. And here's another example of this spammy behavior. So for example, we might want to look not just at, so we found some sort of behavior here that we want to understand. It could be quarantine, it could be Ramadan. But for example, we want to understand what triggers people. So people actually say, oh, this was such a trigger. So say we have a subtopic that we want to examine. This is a cute thing that people do. You can visualize these frequencies or these scores using a word cloud. Oh, beautiful. So although this is not like scientifically interesting at all, people like doing it, so I included some code. I've actually had journals asking me not to do it. They said, it's hard to read, please include just the table. But the table is like half a page, so I was like, but the numbers are not important. So you can argue both ways. So for example, some of the numbers, the odds ratios are not really important to show. So people do this. And I have some papers with them, I admit it. Okay, so let's look at a particular dive into a topic. So for example, we have some words that are about trigger, people mentioning triggers. We put them in one data set, so we're not doing the distinction between before and after, and we do similar tokenization and counting, and we, of course, find people talking about triggers. And so what I'm going to do here is do a baseline of tweets that do not mention trigger. So I want people, I want to see that the words that are more associated with this concept. And we do the similar, so they are about many things, but not trigger. And we compute again the odds ratio. And we find things that are associated with triggers, witchcraft, confiding, people swearing, jogging. I'm not sure what this is. Okay, so we find some trigger warnings, probably chocolate. And what we want to do is say, how do they relate to each other? And that was a question in the previous in the previous day. So we found some words that we want to understand. What we can do is, okay, we found some odds ratios that are associated with them. We can do a word co-occurrence network. So some of these things you've seen before. What we can do is take our data set and apply a count vectorizer to it. And say, okay, we have for each document, the array of, this word exists, this doesn't, this exists, this doesn't. And what it is saved as, it is a sparse matrix because most of it is 0. We've already talked about sparse things, right? So here we basically multiply it onto itself, and we get a co-occurrence table. So like if in this tweet and in that tweet they co-occur, then there's like an entrance in them. And we have our vocabulary of, because here we just have arrays that don't have any words associated with them, but the vocabulary is in our model, so we can go back to it. So we select only the words that we're interested in, and find basically in this co-occurrence matrix only the terms of interest. And there they are. So this is adjacency matrix, which you've heard of before in the network lecture. So basically for each one, we have, how much the column word is associated with the row word. Okay, and so what we can do is, okay, we can make these triplets, warning and trigger are occurring 35 times, and then extremely triggering occur 8 times. And what I want to do is actually create a GraphML file out of it. So this is an extremely verbose way to do it. It would be way easier to like make a network X instance and say to this, and it gets written. But here you can see what it looks like. Basically, you define your nodes and edges, and you can have something associated with each one. So for example, for the nodes, I can give them a label, what word they mean, the count, how much they appear in our data. And for the edge, we can tell them how weighty is the edge between the two words.
Actually, it's good. Yelena, thanks for showing this, because in the network lecture, I only quickly show that you can export a network X object to a GML file, and usually it gets very big because of the price. But then you can show them again.
Yeah, exactly. So the good part about this is that we've already selected some words of interest. We didn't do it for a whole data set, right? We just said like these top 30 words, we want to visualize them. So this creates this GraphML file. So what you can do is load it into Gephi. I will have to do this. Okay. So there you can mess around with it. It's very fun. So this is a random layout. It looks like, very difficult to understand, but you get to these layouts, and there are all kinds of fun things you can do. So for example, here the force atlas basically uses the force between the nodes to position them, right? If the node is very central, it will be in the center. If it's further removed, if it's not connected to other things much, it will be further away. So you can see like things that are related actually closer by. I think we can do expansion a couple of times. Oh, we can see it a bit better now. There are other things like you can give the nodes labels. Now we have the words. You can color them certain way, etc. I think let's look at the preview. And then, I mean, this is ugly, right? This is difficult to read. So in the end, you can actually make them into a beautiful PDF with lots of settings that have nothing to do with the network itself, but with how it looks. I think you can show the labels here, etc. So one of the things we can see, trigger is in the middle here. Maybe let's take the opacity of these things like down a notch. Now we can see things more. So trigger is in the middle, and then we can see some of the things related to it. And here we see a big cluster. What do you think this may mean? That they're all connected to each other? Any guesses? It means probably is that it's the same tweet coming over and over and over again. We might have discovered another spam or something that is quoted a lot. So if a bunch of words are collocated together and are tightly connected, it could be that somebody's posting the same thing over and over again. Okay, so these are the things then you can redefine, normalize like edges and drag things around and show them in different things. But often I find this is a good snapshot of a topic, right? Like different parts of a topic, things that are related and things that are not related. Yeah.
We see just some words but there's some word groups, and we try to find, for example, the relations of the words with the triggers, for example.
Mhm.
Warning triggers. It's a kind of phrase. For example, there's kind of phrases for word groups, climate change.
Yep.
Is it possible to see the frequency, the climate change, or kind of word groups in there, just seeing word by word instead of just single word? I mean,
I'm not
there's
sure I
a
understand.
frequency, it's a climate, it has a kind of a frequency approximately 50, and change is also nearly 50. But it's possible to understand that, okay, this is climate change should be a kind of phrase,
Mhm.
and I should combine it and show it just like
Yeah.
word.
Yeah, exactly. So I think this you would do before making this. So basically, in the step here where you're looking at the different concurrences,
Yeah.
right? You might say, okay, I'm going to count it as one word.
Yeah.
And then you would actually have to go back and say, okay, this is a specific word, treat it the same, and then redo the co-occurrences. Also, one way to say, oh, we already know that there may be two word groupings. Instead of doing it word by word, you can look at co-occurrences with n-grams bigger than 1. You can say, let's compute 2 grams, right? 2 grams and 1 grams. And then, you can do this for phrases as well. But in the end, however you do it, a lot of it is a bit of manual, knowledge. Like trigger warning, I know is a phrase. So you may have to go back and,
Maybe I should clean or do something.
Yeah.
else to get.
But it's possible. Okay, so yeah, so this is a lot of fun. You can make really beautiful representations of your topics for your papers. And in the end, here I want to tell you about this resource called LIWC, LIWC, that stands for Linguistic Inquiry and Word Count. So this is basically a dictionary of words that are grouped in different categories. And these categories were somehow defined by experts in psychology and linguistics and whatnot, not computer scientists. But basically, they give us some understanding of how people use words. Some of them are very generic. Basically, they're parts of speech, right? Like I, you, etc. But some are a little more topically defined. So, for example, there are some mentions of males and females, but things like achievement and eating and some sexual words, body-related words, etc. There are positive and negative emotions. You can see here. So this has been used a lot in trying to understand how people talk about a topic. To say, for example, about people who are struggling with depression, maybe they talk about themselves more than others or something like that. So I think it's possible to get a license to this LIWC. In fact, it is a program. So I think the better way is to, ask for a bit of money. It's not very expensive, and apply the app or the program to your text. I think because it handles negations, right? If you say not this or not that, it actually counts it properly, especially for the sentiment. But say that we're poor, right? We just have money for downloading the dictionary. And we basically have some dictionaries of this thing. It's even dated 2015, but hopefully it's not so bad. And so we have our categories in our data set, and we can define some function to match them to our words. So what it produces actually is, for a tweet, it will give us scores for each of these categories. So there are 73 categories. It will say, okay, I found 9 words in this category, 4 words in that category. So you can do this matching, and then you can say, okay, here I'm putting the category name to it, so you can see what is actually being shown.
It's a dictionary base.
It's dictionary.
Every category has its own dictionary words.
Each category has a list of words.
And can select categories.
Yes, so you can say, aha, I'm particularly interested in prepositions.
The important question is that is there any Turkish dictionary within this algorithm?
Sorry,
For the Turkish text,
I think they do have look for other languages other than English. I do think they have it. You have to go to their website and see. It's a very popular tool, so I think it's been translated to many languages. Turkish, I don't know.
I can answer that question because the person who kind of involved in Luke was an university that I graduated from, and his answer to the question regarding using Luke in other languages was that he thinks that Google Translate does such a good job that you can just put the language that you would like to use from language and translate
Oh.
English and then apply the English version of the language that was his approach to using Google Translate languages.
Okay, so you translate the text and then apply the English one. Yeah, actually, Google Translate is pretty good for a lot of languages these days. Yeah, and a lot of these things are not like very particular topics, right? Like the Google Translate probably will get the pronouns right? Or actually not necessarily pronouns, but for some other things, yes. The pronouns may be slightly more difficult, as we've talked about the biasing, the bias lecture.
what about the words are not clustered any categories here?
Yeah, most words are not anywhere in here. Yeah. They're gone. I mean, it's not something that we found in our dictionary, so we cannot say anything about them. The best thing, so the nice thing about this is that it has some generic categories that are often useful for people that study linguistics. But if you have a particular question in mind, do people use this sort of grammatical thing, you might want to do a particular classifier for it to better find it in your data. Okay, so we apply it to our data. So for each document, we have all the categories and the counts. And then we can say, okay, so we have, for example, 2 categories. We have, let's see, where am I? I'm not sure. So for example, I have 2 data sets, one on anorexia and another on body positivity. So kind of the opposite almost, people say, love your body. And we can apply these, the look to them and say, well, how different are they? So you can then plot some of the categories, look categories, for the 2 different groups that you're comparing. And so, for example, box plots are very good because they give you the distribution of the scores. So like averages often are not so good for this sort of thing, but you can say, aha, so the anorexic group is using pronouns more than the body positive one, or, something about other ones. So one of the things that I would actually say that is kind of generic about data science is that because we have so much data these days, that classical tools for statistics often break. So often you could even say, well, is there a statistical difference between this and that? The answer is yes. You can face the statistical difference between anything because you just have so much data. Because often p-values in many of the tests, they basically get more and more sure the more data you have. So you can just throw millions of tweets at it and you find differences in anything. So you might want to compare not just these p-values, but actually how much the difference is, right? If there is difference, if it's this minute little thing, then nothing interesting to report. But this is true for text mining, but for any sort of data science that you might do. Yeah, and just this last bit, just kind of makes a point about it. I think I'm comparing here the negative emotions, and they're very different. The p-value is very low, but I'm comparing the positive emotions that look very similar on the thing, on the plot, but the p-value is still very low. So even things that might be very close together might be significantly different just because they have a ton of data. Okay, any questions about this case study? Okay, and I'm going to take the 15 minutes that we did not do the lecture, and I'm going to give you another little preview of the next thing. I hope you will forgive me. Okay, so another case study that I wanted to tell you very briefly about is on loneliness. So the social scientists here, have you heard of bowling alone? One? Come on, 1, 2, 3, okay. For the rest of you, this is a very influential book, I guess, that basically recorded that over some time, and especially in the US, some social structures have become less common, and people are more alone, right? And maybe have a subjective loneliness experience as well. So I guess I'm not sure if it's extendable to other countries, but basically loneliness affects your mental health. And in this recent study, we basically said, okay, how did people talk about loneliness during COVID? Because if you're stuck at home for many months, it might get on your nerves, or if you have to attend a conference virtually. So you can see we actually did some of the topic visualization using these colorful little things, word concurrences. But it was also interesting to look at it over time, and it's this time thing that I want to show you. So the methodology was really keyword oriented, people mentioning loneliness. We did data refinement using a classifier, because just because you mention loneliness doesn't mean that you say that you are. There could be some sentiment analysis, and we did some detecting change over time. One thing that I want to do a quick slide about is data annotation. So a lot of, so right now we've been kind of saying, oh, we just take this data from the ether, and it's already annotated and beautiful. Well, often you have to do it yourself. For example, for self-experiencing of or self-declaring loneliness, there were no data sets. We had to make it. So often you have to do it. So we could do the deductive coding where you're saying, I'm interested in this particular class, and say, I am just going to say yes or no for each document, which is very easy. Or if you're doing exploration, you can do something that's related to grounded theory, where you explore and you put the labels that you think are appropriate somehow. So it's more annotation. So here I'm flashing a nice guide for coding if you ever need to do that yourself. And you can do something like crowdsourcing, where if it's a simple enough task that any people with common sense can do, you could just give it to them and be like, okay, random people on the internet, here are some tweets, label them. It's also possible. Okay, so just quickly, I want to show you what it would look like. Go away, go away. So first, I want to show you another example of text classification that you've already seen in previous lectures. Here I am using set that we've manually curated. And basically, so we have self-disclosure and irrelevant tweets. And we clean them using the clean text function. And then we calculated a few features. So we used, actually not TF-IDF, we just used frequencies count for some 1, 2, 3 grams. And basically we used it on the clean text of our data set. We added to this a few other features, whether or not the tweet was directed to somebody, whether it had at somebody in the front, how many capital letters it had, and how much punctuation it had. We thought it might be relevant. So we have our output variable that is quite balanced. We have good representation of both cases. We built a model. In fact, we did some search for good parameters here. And we evaluated using cross-validation. So breaking the data set into chunks, train on this, test on that, train on this, test on that, many times. And our performance was not great, but it was better than having original data. So in fact, what it means is that we had a pretty good recall. So out of all the loneliness tweets, we could actually get a lot of them, but our precision was not very good. Like those that we do get are often not really loneliness, but we couldn't improve it anymore, so we went on. So we train the model, we apply it to our tweets. So this is where we process the tweets, and in the end, we get some kind of sample of our tweets. But if you do this for a lot of your data, you can actually look at it moving over time. So this is a time series of these lonely tweets over many days. And what you can do is you can graph them. What do you think these downward things are? What happened here? When I got very few things. A what? There is so COVID starts here, but this is before COVID. These are outages. This is when our server went down and I couldn't collect data. So, so it's not like from all of a sudden, there was like sunshine and birds and everybody was like not lonely and people just stopped posting. No, I just couldn't get the data. But actually these two peaks are funny. Can you guess what is around this time, around this peak? Not vaccinations. It's Valentine's Day. Valentine's Day is the loneliest time before and during COVID. So I do a few things, like I go back to my original data and I actually count how many hours I have missing data. And when I say, well, at least if I have at least, I don't remember, 2 hours of missing data, I'm just gonna say that this count is no good. Like I'm not gonna do this. So in fact, what I do is I interpolate somewhere here. Interpolate, yes, here. So I basically smooth it. I say, okay, I don't know the precise number at this date because it jumped, but I looking at the ones around it, I interpolate it. I just say, I take an average between them. And then it looks much better. So actually, I still don't know what happened here. It smoothly went down and smoothly went up, and I was still collecting data. So perhaps here we had sunshine and roses and people felt fine, but probably maybe Twitter itself maybe had a difficulty with giving me data or something. Also possible. So one of the things you can do is say, okay, well, I visually can see that it went up, but can I say somehow mathematically, right, to convince my readers? So one of the things you can do is super simple linear regression. Basically, what we say is something happened here, and that's lockdowns. So this would be our interruption to our time series. And so we want to model this bit and this bit separately. So we have this formula where saying, okay, our smooth count, we are looking at it using time, just with time going by. And we're separately looking at COVID, does the COVID variable add something to our count? And we actually try looking at it afterwards. So how much over time does it change during COVID? So extremely simple, like this is just counting off 1, 2, 3, 4, 5, right? And this is an indicator variable where it's 0 here and it's 1 here. And it gives us a linear model, and we can visualize it this way. So in fact, this was our trend before, it jumped, and this is our trend after. This trend is very sensitive to how much data you select. So if we just were to select it up to here, the trend would be much higher, right? If we waited for a century, right, the trend would probably lower back down. So this is sensitive, but it's still a good way to say, so basically the way you interpret it is, so before COVID, people were posting around 4,000, actually around 4,000 people were posting daily about loneliness. And the COVID coefficient tells us that during COVID, on average, 1,700 people additionally were posting. And the trends were not significant really before and after. Yes, so I think this is an example of how you combine machine learning, right? Like I had to do a lot of cleaning, a lot of collection beforehand, but then you turn it into some quantitative data that you still have to clean, as you could saw. So in the end, you can, present some kind of quantitative result to your readers. And for your home reading, you can do similar things in comparison. But I'm not going to show this now. So yes, this is the one we did. I have also this R package or R little script that you can see in the project folder, where it illustrates this nice library called causal impact. Causal impact. Basically, you can say, this group of people were behaving like this. This group of people were behaving like that. Something has happened. Did it cause a change in behavior of these two groups? So you can say, so here we, for example, applied it to a public health campaign. So these people saw the public health campaign message, and these people did not. Did those that saw it started talking about something differently afterwards? So it basically, synchronizes these and sees how much impact was, or up and down after the intervention. The package is in R, so you might have to look at it there.
You cannot the same users. I often for the same target users that you follow the home users. Not all. Am I right?
Some.
I mean that same you track the same users before campaign and after campaign.
Yes, yes, definitely. It's the same user that we're posting, and then somehow maybe they were posting differently afterwards. And actually, between the two groups, we want them as same as possible. So they should have the same behavior, the same interests, the same characteristics, as much as we can to be the same. Right? I don't want to compare them. Yeah, the control group should be very similar to the other one, but just the control group never sees my message, and the other one does. That's the thing. Yeah, and there's the R script is not by me, it's by a student, but he did a very good job. So if you have any questions or concerns, something doesn't run. Okay, if something doesn't run, first Google it, and then come find me. All right, thank you. Do you have any questions of them?
Representation.
Any last minute questions or anything? Oh, yeah.
I have a question on the next slide. It seems like a very interesting package. And it seems like it could have many applications. I wonder if there's any instances where it's used in concurrence with lab experiments, maybe in psychology or in like sociology. So is that like an application that you're aware of? Are there any instances of perhaps tracking behavior in person and also online? Is that
What I would recommend is, I think people cite this package. So you can go to Google Scholar and find that citation and see who cited it. So it has like cited by thing, and you see which studies have cited this package, right? But I think even on the webpage of this package, they have some examples as well. Yeah, I think, do you remember, you're familiar with it, right?
So I think one thing, so this package implements basically a synthetic control approach. Basically, the idea is that you fit your model to your data, but then you use basically you build a counterfactual, and so basically the model basically creates a synthetic counterfactual that is the blue shaded line that you see there. It is what you would have seen
If it
if
didn't happen.
there were no intervention. So now the main problem, the main point of the model is that usually you need a long time series of data for the model to be fitted before the intervention. So I guess in most of the examples you might have with online experiments or so, you don't collect data continuously for a long time from the participants, and so typically it requires. So this is a method that has been originally it's coming from the economics sciences, and usually so you have a long time series, and then you say, well, what happened after an intervention? Then it has been extended also to the social sciences, but thanks to the availability of large data set like this one, and so that's the best, let's say, type of environment where you can use this type of approach.
Okay.
Cool. Okay, so thanks again, Yelena. Thank you very much. So I think so now we have a break, then